Good afternoon, everyone. It is 1 o'clock Eastern Standard Time, so it's time to start our monthly webinar here with CWNP. My name is Tom Carpenter. I'm the CTO at CWNP, and this month we have the opportunity to have a guest webinar. With us today is Vladan from iBwave, and he's a research director there. He's going to be talking to us about the capacity challenge. And this, of course, is a big issue. For years now, we have been evangelizing the fact that coverage is not enough, capacity is required. So whether it's a high density deployment or a standard office deployment, the people need to be able to do what they need to be able to do with the Wi-Fi. And that means more than just coverage, it also means capacity. Obviously, coverage is essential to get capacity, but capacity is that all-important final goal that we're trying to reach with our wireless LAN. And so today we have the opportunity to have an individual with us from an organization that is creating a very useful wireless design tool. I myself had the opportunity a couple of weeks ago to sit through 3 days of training on iBwave Wi-Fi, and I'm happy to say as of yesterday or the day before, I forget which it is, I'm iBwave Wi-Fi certified officially. And so it was a good experience to get to not only go through the tool, but to see their certification process. It is a practical exam, I call it, meaning that you have to actually do the work with the tool and then have someone evaluate your work to approve that you actually knew how to do what the specs were telling you to do. So I think it's a good certification and certainly a good tool to utilize in this capacity. No pun intended there. So today, what I'd like to do is start off with a quick poll to find out from you if you've heard of or used iBwave Wi-Fi as a tool itself. So if you would with this poll, simply say, yes, I've used it, or yes, I've heard of it but not used it, or no, I haven't even heard of it before now. Then this would be useful. I know it'll be good feedback for the folks at iBwave, and I'm very curious to see what this group has experienced as well in that. So I'll give you just a few more moments to go through and answer this. I'm seeing a lot of answers coming in already. And so if you haven't had the chance to vote, please go ahead and do that now. I'll leave it open for about another 30 seconds or so just to get this valuable feedback. Looks like 75% have already voted, so thank you for doing that. And the results we're getting in are definitely very interesting. So about 15 to 16% have used it. Almost half of you have heard of it but not used it, and then another 40-some% have not even heard of it before. So looks like this is a good opportunity for you to get some exposure to the tool and see what it can do. And I know that he's going to be giving you a demonstration a little bit later on so you can see the tool in action. Our goal here is to talk about capacity and how it is required and how you go about accomplishing it. And of course, because iBwave is helping us out with this presentation, they're going to be showing their tool and the capacity features that that tool actually has as well. Okay, so we'll go ahead and close the poll now. And it looks like the final results came in at 15% have used it, 43% have heard of it but not used it yet, and 42% have not heard of it before now. So that's some good feedback, and we appreciate you participating in that poll. And with that, Vladan, I will hand it over to you and let you take off with the rest of this presentation until we get to the Q&A period at the end.
Thank you very much, Tom. Hello, everybody. My name is Vladan Jevremovic. I work for iBwave. I'm a research director at the company. And maybe the reason why a lot of you have not heard about us before is that even though we've been in this business since 2003, is that our start was on the cellular market, specifically for in-building distributed antenna systems. Last year, we have decided, well, actually in early 2016, we decided to step into the Wi-Fi arena with our product, specifically tailored to Wi-Fi markets. And since then, we started meeting some of you. Obviously, 15% already has seen and used our tool, and about half has heard of us. So hopefully by the end of this presentation, we will make a lot of new friends. So the agenda for today's talk is as follows. We'll be talking about factors affecting capacity dimensioning. I have them listed here. I will go individually through each of them. We'll talk about the importance of granularity when we talk about RF propagation, when we talk about user profile, in user profile, in concept of capacity, and when we talk about capacity zones, or what we colloquially call hotspots within the venue itself. Then we will touch on the cellular and Wi-Fi, how they are destined to meet at 5 gigahertz in the near future, and how it would be useful, to pay attention to those 5 gigahertz LTE devices that will be start popping up sooner rather than later at 5 gig. And toward the end of the presentation, I reserved about 10 minutes to give you a really, from my point of view, really interesting demo that will start with a design, and then how we examine whether the design is good or not good, and then how we fix it if it is not good, and then move on to run capacity and see if we fail capacity at any specific band, and what can we do about it. So this is going to be a really exciting demo. First things first, we're going to talk about factors affecting capacity dimensioning. The first one is QoS of applications that we are running. Just a reminder, the QoS types are voice, video, best efforts, and the background in order of importance to the network. Because voice and video are less packet jitter and packet delay tolerant than file transfer, they are prioritized first. So that means that I have to have my voice frames come, more often to the destination than other packets, because they do not really tolerate a delay. They don't really tolerate even transmissions very well. So the number of voice over IP clients that are within AP coverage should be less than the number of video clients per AP coverage, and should be less than the number of best effort clients per AP coverage. So basically what I'm trying to say here is, if we assume that we have a uniform distribution of clients throughout the floor plan, which, so for some parts of the floor plan that is going to be true nonetheless, we basically are going to have to put more APs to cover clients that we know will have, voice over IP as the primary application. So if we can identify areas where voice over IP is going to be the primary use, then we have to have more dense APs there than, for example, in other areas where only best effort or background applications are going to be used. Another type of a factor that is affecting capacity dimensioning is venue type. For retail, we know that we really are going to have a point of sale applications and maybe handheld scanners. And for that, this is really low data rates. And for those, you really don't have to have a very high density of APs around, because there is a low data rate that is being transferred. And that will be reflected in how you set your key performance indicator targets for your design, for the design of the Wi-Fi networks, which we will mention a little bit later. Stadium, on the other hand, is very data intensive. At the most recent Super Bowl, we had about 27,000 simultaneous client connections during the peak usage. Imagine that, 27,000. Now, when you think of it, it is only about 1/3 of the total number of the spectators, which means that about 1/3 or 35% of the spectators were actively trying to send some files. And if you know anything about the behavior of people in the stadiums, those will be pictures, selfies, or videos, basically very heavy file data sharing is out there. So it's no wonder that for such a venue like a stadium, we will have very many APs around. We will have a lot of very high AP density. Hospital, on the other hand, they will have a mix. They will have a mix of applications. They will have a voice application, voice over Wi-Fi. They will have a real-time location, and then there's going to be a data. The vital signs are being monitored, and the vital signs are being transferred back to the nurse desk, the nursing desk. So obviously, you will want to have a mix of applications in mind. But having said that, you always design for the least common denominator, for the weakest link. You design for the weakest link. So if you have a voice there, then you have to treat that like the predominant uses voice, because you want to have more dense AP network. Also, real-time location is sensitive to how what the spacing between APs is. You know, the more dense, the closer to each other they are, the better real-time location precision will be. And other venues also have their own factors that will be affecting capacity dimensioning. For example, what I didn't write in here, but what I could mention is that we have schools, educational, for example. These days, you know that they require each student, even in the middle school and high school, to have a tablet. So they will have examples during class, and everybody is going to be required to use a tablet. Now, which application, we really don't know. It could be from low to high data rate, but just the fact that everybody is going to be using it at once is going to force you to put, one AP to each or maybe every other classroom. So just to let you know, there are examples there where you either have a low data rate, but you have to have a high density because you are expecting that everybody will be firing their device at once. Moving on to the next slide. Another factor is the number of streams per UE, per client, actually. I should have written that per client. Power consumption affects the number of streams. So having said that, the larger form factor client, such as a laptop, will have a bigger battery and can have 3 streams because it can support, the power consumption of a 3-stream client device. Smaller form factor tablets, less, the battery is smaller, so it can support 2 streams. And finally, smartphone, small form factor, and the battery is supposed to last longer, and thus 1 stream only. So this is a general rule of thumb. And what you're going to have in your venue, you're going to have a mix of those. Some people will have tablets, some people will have, everybody's going to have a smartphone, I can tell you that. And laptops, there's going to be some with the laptops. So it is prudent to say that, you will have more than 1 device per user. It is just that they may not be using both devices at the same time. On the other hand, it is possible that they could, have something going on their laptop, for example, a video conference, and then they're bored and they grab their iPhone and then they start browsing the web on their iPhone. So that's a possibility always. Now, moving on, user density, I have mentioned already educational a scenario where we have students that they're all firing, the laptop at the same time or a tablet. So that would be an example of ultra dense network. Another example of ultra dense would be stadium. Then we move on to a little bit of lower density, still dense, that is hospital, because we have lots of patients there, and we are assuming that there is going to be a vital signs monitoring going on in that hospital. Then moving to even fewer users per square foot is office environment, where we should assume that people are going to be connected to the internal network, either via wireline or via internal Wi-Fi network. If they have a laptop, chances are they're going to be using internal Wi-Fi network. Or even if they connect with the wireline at the desk, they may take their laptop or their tablet with them to boardroom. So that's another possibility, you know, that you may have somebody doing that. And in the office, obviously, other applications are possible. And finally, the lowest user density would be in manufacturing. You really don't have that much traffic. It is a low traffic environment, and you occasionally have people scanning, you know, for items and so on and so forth. So those are four factors that we mentioned thus far affecting capacity dimensioning. Moving on, we go into three more. A2.11 technology is obviously has CSMA/CA algorithm, which is collision avoidance algorithm, and it comes with a price. It comes with a complex negotiations protocol, which ensures to minimize packet collision at the AP receiver. And that overhead is different, you know, for different technologies. For older technologies, A2.11a, B, and G, that overhead is about 50% of the available airtime. So let's take A2.11a technology, for example, and then we know that the maximum achievable data rate is 54 megabits per second. Because of the 50% of the time that is reserved, you know, for contention, then only about 50% of the time you can actually transfer data. So instead of 54 megabits per second, your throughput is really 27 megabits per second. And then things are better for A2.11n and the AC. Their throughput can get up to 80% of the listed maximum data rate. The other 20% is for overhead that is the result of the contention algorithm. So basically, why is this important? It's important because that throughput that you have available at your hands is going to be basically the throughput at which you can transfer your files. And the higher the throughput, then, you know, the less time is needed for you to transfer the data. So that is something to keep in mind, because you're actually occupying the airwaves when you are trying to transfer. And every time you occupy the airwave, then somebody else cannot transfer. So we will see how it falls into place when we go into our algorithm, where we actually define the busy hour or a peak usage time, which can be 1 hour, 2 hours, or what have you. And then within that hour, you basically have users trying to send files. And then the higher the throughput, then the less time it's going to take each user to transfer the file, and more users can be fit into that peak usage or busy hour. Another factor is ambient or background noise, and this actually affects both design, KPI choice, and target level. For low ambient noise, we do design for signal strength. And for high noise, we do design for SNR. And basically, what is low noise, what is high noise? Usually it is -90 dBm, which is, if you are less than that, then you're low noise. If you are higher than that, you're high noise, so you use SNR. If your venue has more than 90 dBm of noise. And obviously, you would want to use a spectrum analyzer during peak time, you know, to measure that. Available airtime, it is 50 to 80%, depending on the environment. Stadiums, that's about 50%, and then if you go to the quieter environment, such as warehouse, it is 80%. So those are typically, you have to set, you know, that number before you do the analysis, capacity analysis. You have to know what is your available airtime up to a certain percent. And then granularity. That's another topic. And why is this important? Why is it important to have granularity in your analysis, capacity analysis? First of all, behind every capacity analysis, there is a RF coverage analysis first. So we have to do RF coverage analysis before we do capacity. Why? Because we want to know if we have hit our design targets. That's number one. Number two is we have to do analysis of CCI. If CCI is bad, then it doesn't matter if we hit our KPI targets. Now, if we want to do it correctly, we want to identify areas where we have open area propagation. And in our example, it's going to show up, well, that's really important. Then semi-open, as you see, and dense area. What you see right now is a floor plan of a hotel. In the middle, you have open area with a pool. Then that semi-open area, it's a ballroom. That's where you actually have meetings and conferences. And then there is a smaller, obviously, rooms around as well, right around here. And then there is dense area with where the rooms are, right? So you have very, very different RF environment. And so you need to basically be aware of the fact that they are there and that the propagation is going to be different in those areas. In other words, you shouldn't be using spreadsheets to calculate your radius of your AP for this floor. You need to use a tool that can actually account for it automatically. The next one is the 3D view of the signal. It is necessary for a multi-level building. You see that the hotel not only has this first floor, it has, you know, second and third floor. So basically, you need to be able to account for difference propagation on each level. I told you that CCI prediction is important, but look what's going to happen if you do it in 2D only. Well, this design obviously is not very good. At 2.4 on the left-hand side, you see a lot of CCI equal to 3 over the area smack dab in the middle. But it gets much worse if you look at what's going on when you take into account the CCI contribution from higher levels. You see that CCI goes up to 10. Well, you know, and in this area, big area, it is 7. It is not 3. Then there is areas with 8 and 9, obviously, but you know, this is really a big mess. But you don't get to appreciate how messy it is unless you do a full 3D CCI prediction. 2D basically tells you this is not good, but you know, we can probably fix this. But 3D is saying you really need to rethink what you're doing. User profile granularity. Well, you know, most clients run a variety of applications over a period of time. So it is important to specify the period of activity in increments of hours, you know, for the peak usage. Applications that are likely to be used, email, browsing, file transfer, and the quantity, number of emails that you get, number of web page visits, number of files, etc., and file size in megabytes per unit. Well, it gets really complicated, but you know, what it really boils down to, you need to specify how many megabytes each user is going to transfer during peak hour. Now, when I said that, that is much more palpable. You basically have to say, okay, 100 megabytes per user during peak usage. Okay, good. So we can work with this. But point being is that we have, you know, not just one application, we can have lots of applications going on there. And those we, you know, store in what we call user profiles. So you can go and store a different user profile for a different environment. If you are a system integrator, you really do appreciate this because obviously user profile for a hospital is not the same than user profile for a stadium or office environment. Capacity zones granularity, another nice thing to have. As I told you, assume uniform distribution on the floor unless it's not uniform. And it's not uniform if there are hotspots. Okay, so what is a hotspot? Well, it is your cafeteria if you work for a large company. It is going to be very busy during lunch hour, and the density there is going to be very much different than the density of the clients throughout the rest of the company. So just one example. In this hotel, we have three examples. Different density is in hotel rooms, different density in conference rooms, different density, at the reception desk and client desk. Having said that, these areas may also have a different usage pattern. Hotel rooms, mostly standard definition and high definition videos. Reception desk, web browsing. In conference rooms, emails and file transfers. So you can do that. You can say, basically, here is my reception desk, and the client profile is such and such, and here is the room, area. The client density is such and such, and the profile is such and such, and then do analysis. So you see granularity increases with each step. Now, the next topic to cover briefly is cellular and Wi-Fi. A lot of venues have a mix of small cells and DAS and AP, and we really have seen a lot of cellular carriers offload their traffic to partner Wi-Fi providers. The offloading mechanisms, they may vary. It may be offloading by application type, voice versus video versus data, offload by signal KPI threshold, or offload by cell load threshold, cell load at the carrier base station or eNode B. So bottom line, some customers are on cellular networks, some on Wi-Fi, and the percentage breakdown of cellular and Wi-Fi customers needs to be specified. This is done in each capacity zone. So if you are happen to design for both cellular and Wi-Fi, you should specify the percentage of one versus another. So anyway, our solution is iBwave Wi-Fi Suite, and basically what we have there is the solution that can accelerate Wi-Fi deployments by 50%. It can ensure carrier-grade Wi-Fi, and it can reduce project cost by 30%. It has full database of parts, over 25,000 parts. We've been in business for a long time, so we have built a rather large database. We can do collaboration easily with your project partners by storing the files in the cloud. We do have that solution as well. And you can manage all your projects from a central hub. So that's what our Wi-Fi suite can do for our customers. I'm going to give you an example. First, it's going to be just on a few slides, and then I'm going to go straight into a demo. I'm just showing you how we actually, what our capabilities in 3D modeling are. This is a Holiday Inn hotel with a pool in the middle. And this is how it looks like full view with the walls and the roof and the details of each level. This is actually what we have, like a wire mesh presentation. And why is it wire mesh important? Because when you have wire mesh view, then you can actually see where your APs are. Those black dots, those are APs throughout the venue. And this is shown as antennas here, but there really are APs. This is, holdover from our DAS days. Occasionally we have that in our tool. And then equipment is there. See the cables, the cabling. And then finally, what you see is a 3D view of the signal level. So it basically gives you on each level the heat map for a signal level. And then the next one would be your average downlink data rate per client. This is not maximum achievable data rate. This is data rate per client. So this is at 5 gig, right? So having said that, let's move on to what we are going to show you as an example, as a demo. So this is that hotel. This is a 2D presentation. I have chosen to give you a 2D presentation because it is easier to make a point. But what I want to tell you first is about this design. The target was to have NEG 70 dBm as a KPI, to have it, between NEG between 85 to 90% of this floor plan. And you see right now, NEG 70 dBm, I'm at 87.8. So it looks like I'm doing well there. This is 2.4, but you would notice in this design that obviously not all of them are active, you see, because I have a design at 5 gig as well, which is the one here, which I did not give you the coverage. I actually should do analysis. I will do it once I do optimization. Well, anyway, but this is, what I have. I have placed initially this AP in the middle, right next to the pool area, thinking, well, I need to cover the guys that are by the pool. I have put one in the area in front of the ballrooms, because I'm thinking this is where the people are going to mingle before they move in. And I have also put one inside to provide for capacity. There is one to the side to cover these guys capacity-wise. And then also I basically put them throughout this area where the rooms are. But what I did there is, take a look at this, is I let the power be at 20 dBm, full-on power. Don't be confused. I have put generic AP access. I did not want to put anybody on the spot as far as OEMs. So this is generic, 20 dBm power, full-on power at the 2.4 gigahertz. So now, most of you are laughing already. Well, this is not a good idea, because even though I have gotten a nice coverage there, when I go into co-channel interference, look at that. What I have is this CCI equal to 3 throughout this area, right? So the first thing that I need to do is I need to get rid of this nasty looking red area and try to maybe have CCI equal to 2. If I cannot completely get rid of CCI equal to 2, I'm going to try to get rid at least of CCI equal to 3. Okay. Why do I want to do that? Because the higher the CCI, the lower the data throughput per AP is going to be. So I can go and do my my capacity thing if I have this mess of a CCI coverage. So what I did, and now I'm going to open another window that's going to show you what I did here. So I moved that one that was in the middle of the area, open area here. I also reduced the transmit power. That transmit power is neg 5 dBm. Okay. I've also reduced the transmit power of those APs that are in semi-open area, such as this one, which was near the ballrooms, as you see. This guy is now at 0 dBm. I also reduced the power of that guy to 10 dBm. And I think this guy as well is at 0 dBm. So basically, I'm trying to do the coverage control by reducing the power. The price I pay, I'm at 80%. I'm at 80% now. What I can do is I can probably go in and turn this one on, which is going to improve the coverage in this area right here. And tinker a little bit with the APs, and see to maybe increase the power, move maybe this one, move closer to here, etc., etc. But this is you get the idea, what I was doing. And then the co-channel interference, we look at that. CCI equal to 3 has disappeared. It is not there anymore. So I have at least got rid of CCI equal to 3 and increased, increased the area with CCI equal to 1 and CCI equal to 2, but I think I increased the CCI equal to 0 as well a little bit. We can go and we can check this out. Yeah, CCI equal to 0 was about 32%, and here is 36, and I increased the other two. So what I did on that level should be done on the next level and the level above. Okay, you optimize for each level, and then you do the 3D analysis of CCI and see, how much better you have become. And now we move on into capacity. So here is where we define our capacity. As I told you, we can define the for each floor, you can define the number of clients, and then you can, in a usage profile, you can say what is that you have. Right now, I have defined this as a hotel, but I have others, as options that I loaded up in my database that I can use if I want to. I specify the breakdown between cellular and Wi-Fi because somebody, will not be able to use maybe Wi-Fi for whatever reason. Usually when they're when they are registering at the hotel, they still did not get credentials, so they use cellular. You can define per zone, as you see here. And, I have on floor 1, I have different areas. I have a lobby, I have pool, I have a cantonada, which is those conference rooms, and gallery, I think, is a conference room as well. So usage profile is for a conference room, and so you can define that, and that is a granularity that we talked about. You basically draw, the areas around the hotspot, and then name it, and then you say how many clients, and you assign usage profile, and so on and so forth. The next thing that you can do is market share. Mines are 8.11n, so I can define a split between 2.4 and 5. And airtime utilization, we said that it should not be more than 80%, so 80% it is. For the hotel, I'm assuming that it is not like stadium when it's only 50%. So I'm assuming that I can go up to 80%. And the breakdown, UE type, we call it. This is holdover from our cellular days. It is client type. So some of them are 1 stream size, so some of them support 2 streams, some of them 3 streams. We talked about that. You're assuming that not all of them will have the same capability. Now, usage profile. This is where you actually can store different usage profiles. You can define different one for airport, different one for cafeteria, conference room, etc., etc. And finally, this is the one when you define a subscriber service. This basically has to do with the file size and the duration of a typical file size transfer for streaming devices. In other words, you define, a typical use here, and then here you refine that by saying, for example, in cafeteria, I'm going to use 3 emails, 6 minutes on online gaming, 10 pages of web browsing, and all that transfers to the size in megabytes, and then you get a total size. So in cafeteria, it's going to be almost 200 megabytes during peak usage. Now, you have peak usage, let's say 1 hour, you have a file size, 200 megabits per second. What you do see here is average throughput. Doesn't mean that I was transferring, that much, during that peak usage. I will transfer a bit, and then I'm going to be silent, transfer a bit, then be silent for a minute or 2 or 5. This is average over peak usage time, which is in increment of hours. Okay, having said that, I'm going to complete this presentation by telling you that I'm going to run capacity now. After I defined all this, I'm running capacity at 2.4. And what is going on? I'm failing. Okay, so what did I do? Well, here I said that I want to have up to 80% of airtime usage. I ended up 140%. So why is that? It could be that I have a lot of clients there, and they're transferring big files. So these two APs are suffering. They are really not doing as well as I would want them to do, right? So they're failing, and I'm not going to have a very good performance there. So what can I do? I can put another AP there, which is going to mess up my CCI at 2.4. I can say, well, maybe I don't have that many clients. Maybe I have fewer clients there and reduce the number of clients, but hopefully, we put the number of clients that we did originally for a good reason. So that is out as well. What I can do is I can go in here to market share, and I can say, all right, let's say that I force clients to be mostly on 5 gig. It was a 50-50 split, but then I'm basically saying I'm going to do that. And you can do that within an AP. You can log in and you can say, this is the percentage of clients I want at 5 gig. So once you do that, you then rerun the capacity analysis and see what happens there. And this should be done within less than a minute, I think. All right, so that was at 2.4, and you see it passed now. So everybody's happy, in this area where I had 140% airtime usage, now I have 70% airtime utilization, and my limit was 80%, so I'm good. So the next question is, well, what happened at capacity at 2.4? I'm sorry, at 5. Well, first of all, call channel interference is fine here because we were able to, properly allocate channels. Now we need to run capacity analysis here. And why? Because we just moved quite a bit of clients to 5 gig. So I'm going to run on this plan, and this actually is going to run for about 2 minutes or so because I have a bit more clients at 5 gig than I have at 2.4, which is not surprising because 5 gig is the propagation is not all that well at 5 as opposed compared to 2.4. So you're going to wait a couple of minutes for this to be completed, and that if it is green after I moved more clients to 5, then it means that I did a good job. I did a good job allocating clients to different frequency bands, and this number of APs at 5 and number of APs at 2.4 is okay. So anyway, well, we're still waiting this to complete and should be shortly. This actually this is the last example that I wanted to show you, and this will conclude my presentation. So we just need to wait for maybe a minute more.
Hey, Vladin.
And then, yes.
While this is running, could you talk a little bit about the different propagation models that are available in this tool and how it's actually making these decisions?
Yeah, there are 3 propagation models. I cannot switch to them now where this is running, but we have the ray tracing, which is the most complex, and this one is used to do analysis, okay, of this analysis. By the way, this is done, so I have passed here, so we are good. Capacity passes, on both frequency bands. So this is called ray tracing. This is the most complex, and that takes the most CPU time to complete, but is the most accurate. Then there is another one called COST231, which only relies on a direct path between transmitter and receiver. The ray tracing takes into account direct path, reflected paths, and diffracted paths, which is really important for a 3D analysis. The COST231 only direct paths, and it is decent accuracy if it is not very complex venue. I would not use COST231 for, let's say, a stadium or maybe even this hotel maybe not be the best choice. But it depends on the size and the complexity. And then the least complex is another variant of a one slope model, which is called variable path loss exponent, which we already have. It is very light on a computation time, but its accuracy is limited. We have all three of those in our offering. So having said that, I'm going to now switch to my parting slide, and with the information, oops, I need to change display settings, swap, yes, and then I'm open to questions now.
Okay, excellent presentation, Vlad, and a lot of good information there. His contact information is provided here on the screen. So if you want to follow him on Twitter, you can do that. And you can also email him if you have questions beyond what we have time to get to today. I'm sure he'd be glad to hear from you. And we do have several questions that have come in, and we'll get to those momentarily. Before we do, I just want to share a couple things related to the polls and so forth. So here's a poll we did for those of you that might have come in a little bit later at the beginning, just so you can see the results of that poll. And we're just asking how many have heard of iBwave Wi-Fi or used it. So some good information here, and I'm glad we've had this chance to expose you to this tool. But one other poll that I'd like us to run very briefly is just a question regarding to problems that you're facing. So we're going to run this poll here for about a minute. And the question is, which one, not which on, but which one of the following would you say is the most common problem you have in your wireless LAN? Clients unable to connect, older clients slowing everything down, insufficient data to make good management decisions, non-Wi-Fi interference, or insufficient throughput for devices. So I'll give you about a minute to vote on that. We'll get some good statistics about the problems that you're facing on your networks. And then we're going to get into some of these questions that have come in. And while this poll is running, Vladen, one of the questions I know that came in was whether the same capabilities are in the regular iBwave tool as what iBwave Wi-Fi has. I guess the point is, can you do both Wi-Fi and DAS or something else in the regular iBwave tool, or do you have to have iBwave Wi-Fi to really do Wi-Fi design?
You can, if you have iBwave Enterprise, which is our regular tool, you can do both. You can do Wi-Fi and DAS. Basically, the way it's organized by us is by technology. We have a list of technologies in our network optimization module, and technologies are, both 802.11 and any cellular technology that you could think of, and then there are public safety technologies there as well, like LoRa, for example. So the answer is yes, you can do both if you have iBwave Enterprise. And iBwave Wi-Fi, this is PC version that you've seen today. That was actually made specifically for those that are Wi-Fi only users, and was priced accordingly.
And the new tabbed interface we had the chance to see today, the kind of ribbon bar, kind of like Microsoft Office, that was introduced fairly recently, wasn't it?
Yes, that was earlier this year in version 8.1. That is available at this point only for iBwave Wi-Fi, not available. The Enterprise still has the old interface. The new interface that you've seen is unique to Wi-Fi look, and it was introduced, I would say, maybe two months ago or so.
Okay. And I will tell you, having gone through the 3 days of training on it, it's a pretty slick interface. It does make it pretty intuitive as far as the flow of going through the process of creating a new project and getting everything set up. So I thought it worked well. We'll give about another 10 seconds here if you haven't voted yet, but you can hear that we've got a poll going. We're at about 66% voted. So if you can jump in there in the next 10 seconds or so and give your vote, that'd be great. And we'll close it out here in just a few seconds and see the results. Okay, we have just reached 70%, so I will go ahead and close this poll now, and let's take a look at the results of it. So here's what we see as far as the most common problems that people are facing on the wireless LAN. 43%, the biggest one, insufficient throughput for clients. And of course, that speaks right to what we're talking about today with capacity. So very important topic. The next one was 27%, insufficient data to make good management decisions. And I think that is a key factor and does tie into one of the questions, Vladen, that someone asked that I'll bring up here momentarily. Then we've got 12% clients just unable to connect, maybe a coverage or interference issue there. 11% older clients slowing everything down. I think we'll always have that pain point, it seems. And then 9% non-Wi-Fi interference. So that's some really good information from the group. Thank you for sharing those insights. And hopefully, at least maybe some of you now know that others are also feeling your pain. So with that, let's go ahead and go to the questions. And one of the questions that does kind of speak to insufficient data, because I think that your tool can help to provide some of the data that people need to make good decisions. One of the questions that was asked, Vladen, was, if I can find it here, so I can ask it just as it was asked. Okay, so it says, can this tool be used for real-time assessments? And I think what they're asking is, can you do active surveys with the tool?
Yes, that's probably, yes, you can do active and passive survey. We do provide that option. That is correct, yes.
So basically, part of this problem of having insufficient data to be able to make good decisions, particularly in post-deployment. So we've seen today the power of the tool to be able to create your plan, to be able to simulate or virtualize the plan and see what it would look like in production. But the tool does also allow you to do the standard walkabout survey, gather that real information, and make some good decisions from that as well.
Yeah, it does, yes.
Okay, let's deal with some other questions that have come in here. One of the questions was, is there a difference between iBwave Wi-Fi and doing Wi-Fi designs in the enterprise? And I think what it's getting at there is this a tool for doing enterprise Wi-Fi design?
Doing enterprise Wi-Fi design. Okay, I see it is, okay, it is a play on word. We have actually, our original tool used to be called iBwave Design. It is now called iBwave Enterprise. So we have renamed that from iBwave Design to iBwave Enterprise. Yes, you can do enterprise design with either iBwave Enterprise or iBwave Wi-Fi PC. Okay, basically what we have done is we have taken the Wi-Fi portion of iBwave Enterprise and packaged it and sell it as Wi-Fi only tool, specifically to address this segment, specifically to address Wi-Fi users that perhaps would not have any need for anything else in our tool. And that was done, so we can lower the price and target this particular segment. There is absolutely no difference in what you can do in designing Wi-Fi networks in iBwave Enterprise as opposed to what we are offering in iBwave Wi-Fi PC. iBwave Wi-Fi PC is just as powerful for designing Wi-Fi networks as is iBwave Enterprise when you are using the technologies that are 8.11 technologies.
And iBwave Enterprise is going to add then DAS deployment capabilities and things like that as well, right?
Yes, absolutely. Yeah, you have seen, here that I have when I showed you in capacity calculation how you can actually say how many percent of the clients goes to which technology. And in our iBwave Enterprise, you can actually define those technologies for cellular networks, which is going to be served by DAS. So when you are doing the user profile in Enterprise, you are defining the traffic and the cellular networks, which is DAS networks, as well as Wi-Fi networks. You're doing splits between Wi-Fi and cellular, and as you have seen, we have done a definition on Wi-Fi traffic. In addition to that, you can do a definition on the traffic of the cellular frequencies. So that's the difference, basically.
Okay, excellent. Another question Howard asks, and I think I know the answer to this, but he says, can you define your own usage profiles, or are they hard coded? You just have to use the ones that are built in.
Oh, no. You can do yours. What we have found out in our work that a lot of people are actually asking us for guidance. They're saying, that, well, I'm relying on your default values. You have to basically put something else, and you have to put something that actually makes sense as the first, approximation. So that's why we have populated those. And, the purpose was, first of all, that people can have something to start with. And number two is to try to cover as many verticals as we can, right? So if you're a very experienced user, then you're quite welcome to go in and, open it up and put a new user profile and name it however you want and define the usage, up to your liking. Absolutely, you can do that. You're not stuck with what with the suggestions that we have given you with those default values.
Okay, excellent. Another question Paul asks, and I want to make sure this gets answered before we run out of time. He says, can we get a fully functioning demo or trial version of this?
Yes, you can. Obviously, you can contact actually at what was the name of it's on the web page. If you go to iBwave.com, you will find how to contact us to request a demo. They will ask some information from you, and then you will get a demo. Typically, I think demo is for 2 weeks. Yeah, 2 weeks. You get 2 weeks for a free trial, and it is going to be fully functioning in the sense that you will have all those features.
And they should know too, built into the demo, right when you go to the start screen, there are 6 or 7 videos that step you through the basic processes of using the tools. So you can fire up the demo, watch the videos, and within an hour or so, be ready to start working with the tool to see what it can do.
Yeah, that's you're right. That's absolutely correct.
I'm going to
yes.
send the link to everyone.
Okay. Amna is going to send a link to everybody in a second. Anna Chisti, who is with the marketing department, who is with me in the conference room, she's going to send the link.
Okay, excellent. And in addition, another question. We've got just a couple more minutes here for questions, so we'll go ahead and address a couple of important ones here. One question came about the example you gave about the Super Bowl. They're just curious if you know what the download rate per client on average was for the stadium, and how much you feel that channel bandwidth plays a role in reducing airtime utilization.
Okay, those are interesting questions. Okay, so how do I know about the Super Bowl? Well, I heard that at the conference we had in Phoenix a few months ago. There was a presentation, and somebody mentioned that there was 27,000 connections. I don't recall them saying what was the throughput per client there. I really have no idea. I would have to go and watch a video of that presentation. And Tom, you're welcome to mention which conference it was. I'm not mentioning it for right now because I don't know if we should or not.
Yeah, and that was the Wireless LAN Professional Conference that Keith Parsons puts on. And if you do a search for Wireless LAN Professional Conference online, you'll find his webpage, and he's got all the videos up there, so they can certainly go watch those as well.
Yeah. Now the second question was the channel bandwidth. That's a loaded question. On that same conference, I remember there was they were talking about some network that the health of the network has actually improved when they killed off the 40 megahertz channels. Obviously, you shouldn't be using 40 megahertz channels. That's 2.4 gig. But I think they were talking about 5 gig and saying that the health of the network improved when they went from 40 megahertz to 20 megahertz. It all really depends on the size of the network, and how busy the channels are. For example, here at the headquarters in Montreal, we just looked into what is going on at 5 gig this morning, and we've seen that maybe of those 22 channels, 20 megahertz channels. Maybe one, interestingly enough, channel 36 and the last channel, they're really busy. There was like 15 clients in each, and in between there was nothing. So yeah, in this case, I would go with 40 meg easily. But if I see the network that is a bit more uniformly busy at 5 gig, I would go from 40 to 20 and see how that goes. So that's the answer to that question.
Yeah, and I think when it comes to channel bandwidth, it is a case-by-case thing, with the exception of 2.4. Obviously, there we always want to use 20 megahertz channels. But in 5 gigahertz, whether you use 20 or 40 is going to depend on the scenario, how dense the environment is. A lot of factors are going to come into play, so I think that's a good answer. We're right at 2 o'clock right now, but I do want to get a couple of these questions in that are here. So we'll go over just a minute or so. I apologize if any of the attendees have to run, but I think these are a couple of really important questions. First of all, is iBwave sold direct or through resellers?
We are doing both. You can buy direct from us. You can buy from resellers.
Okay. And then a design question. The question is the iBwave Wi-Fi suite capable of simulating tunnels, subways, or metro stations, those kinds of scenarios?
Yes, we are. As a matter of fact, we did a bunch of case studies in 2014, 2015 on just that, on subways and on what was that? There were a few others, stadiums, subways, and those were for DAS actually, not for Wi-Fi. But since we are really not doing anything different propagation-wise for Wi-Fi than what we are doing for cellular, then the answer is yes. We can do analysis there. If you go to our webpage, if you are interested to see what is it that we did for case studies, Amna can send a link for those case studies to our webpage so you can download them and take a look. I warn you, it is about DAS, but it does cover capacity and others.
Okay, excellent. And another important question here from Paul. He says, can you import the results of a full survey, import it, and then use it to optimize a simulated one? And in addition to answering that question, just so everybody knows, you also have a tool that runs on mobile devices, right, that you can gather data from and import into the PC version too.
Yeah, so let me explain what we do with the survey data. You can get the survey data, and then what you go off is do the propagation optimization, right? So, for example, you are capable of actually, let's say that you have only one AP turned on, right? You're going to go on and you're going to log into that. You're going to take the data from that AP, and then you're going to import that in our tool. And then you are going to assign that data to that AP, and you are going to do the optimization of propagation coefficients. Once you have that, the accuracy of the prediction for that AP is going to improve quite a bit. And that's how you optimize your prediction. Okay, and then you can even go ahead and do analysis of the error analysis after you did optimization. After optimization, you shouldn't be expecting to see zero error, okay? The error is still going to be there. So, people that have done this in the past, what they do is take half the, data for optimization, the other half to analyze how much it improved after optimization. But the short answer is yes, you can, record the data, you can import, and then you can use that data to do the propagation optimization.
Okay, excellent. And I'm going to answer 2 or 3 questions real quick that have come in. One question was, can we do external antennas with our APs? The answer is yes, the tool does provide for that. Another question is, does the propagation tool differentiate between different models of APs? Absolutely. When you bring them in from the parts database. There are different propagation patterns. You can even view the propagation patterns and see what they look like in a 3D space. And so it does differentiate those different APs if you're using multiple AP types within a deployment. And so the last question we'll answer, Vlad, and then wrap things up today is real quick. Can they find any other training from you that's free online? Is there any kind of free training that you provide that they can get access to other than just this webinar today?
Do we have YouTube videos?
We have a lot of YouTube videos and
Yeah, there.
information on
Yeah, if you search us on YouTube, you'll find quite a few videos that are related to our company, our products, and so on and so
on
forth.
our website, and there's the past webinars that can be recorded.
Yeah, there are past webinars that we have done. So we can go to our webpage, register, and then you will be able to see what the past webinars are and access them and watch them.
Absolutely. And also, as I mentioned, there are some training videos within the software itself that are linkable that you can gain access to and see that information as well, giving you 5 to 6 minute clips of doing some of the common tasks you have to do in the tool. So with that, I would like to just remind everyone this webinar today was recorded and it will be archived on CWNP TV at YouTube. So it'll be there within the next few days. And I'd like to thank Vladen and the team from iBwave for being with us. I appreciate you being here, and I know that everybody got some good value out of it. So thanks for joining us today.
Thank you for having us, Tom.
Thank you.
Thank you. Bye-bye.
Absolutely. And everybody, thanks for being here. I hope you have a wonderful weekend coming up, and take care.